Alrighty, welcome to Unit 4. We're starting our next unit of our Algebra II journey. In this unit, we talk about how we can represent functions, right? We talked about equations, inequalities, and now we're moving forward into functions. And so functions are define the relationship between two objects, right? It does not necessarily have to be numbers. It just describes the relationship between two things. And you'll see as we're moving forward a little bit, right? So it takes our independent variable and connects it to our dependent variable. And I'll explain more about that as well, right? We want an input of our function as we're going in and then an output. And some of you may have seen this when you're in middle school, right? You have a box with a rule. This is your rule, which is your function actually. And you're going to input one number in. Let's say I input the box of 1 in, and I get out the box of 2. And so what does our function, what is our rule? And so that's what functions define. And functions are very useful for modeling real world situations and describing the understanding between distance and time. And we'll see a bit more of that as we move forward throughout this unit. And so on the first slide, as usual, define your vocabulary. The goal for today is interpret descriptions and graphs and functions in context. In this introduction, remember, it's just an exploration. That's why we're starting off. And so I want you to read through this and think about your own experiences. Like if you have been to a vending machine, have you understand the relationship between the number of drinks and what the button is being pressed. So as you're reading through, right, the drink machine at your school offers several types of drinks. There are buttons for your favorite drinks. Think about it when you put in your money, you always press the button. Blast, Slurp, Lemon Twister, and Diet Slurp. While buying a drink, Miss Whitney pushes the button for the lemon twister and receives a can of lemon twister. Later, she goes to the same machine and pushes that same button, and this time she receives a can of Blast. And so think about, does that make sense, right? We don't necessarily, I'm not asking you to know the definition of a function as we move forward into our first one, but think about what function means. Is this functioning correctly? If I'm pressing a button for lemon twister and I'm not getting lemon twister, is that a functional drink machine? So I want you to think about that as you are going through. Let me know yes or no and why you think so. Same thing here, right? When Brandy pushes the button for Blast, receives a can of Blast. Her friend Marco also pushes the button of Blast and receives a can of Blast. Diego also then comes and does the same thing. And so you want to ask yourself, is this machine functioning consistently? Is this what is functioning how I expect it to function? And now then we can expand that as well, right? Now think about it outside of context. We want an outcome that is consistent and predictable. So our machine is functioning properly. So every time I press a button, I want to know what I'm getting out. And so our input values here, right? What I'm inputting in the button that I'm pressing is my X, and my output is what I am resulting in, right? This is my output. In the way we describe it right now, this is my independent variable. What I'm choosing to push, I'm choosing to push Blast, I'm choosing to push Twister, and my output is what comes out. What is my result? What am I going to get if I press that button? And that is called my dependent variable. And so I want you to look at these tables and decide if these tables are also functioning properly. When I put out a 7, do I always get a 6? If I put in a -2, do I always get a -3? What is happening here? Is this graph, are these tables functioning properly? And if you need to think about it as a button that you press and something coming out, picture it as that soda machine going forward. And as I said before, this is just exploration. We're introducing you to the idea of functions. And last but not least, right? In the second activity, I want you to, now we're looking in a context of our problem. 3 days in a row, the dog's owner tied his dog's 5-foot-long leash to a post outside the store while he ran into the store to get a drink. The dog's movement Each day is described here. The dog walks around the entire time while waiting for its owner. The dog walks around the first minute, then lays down until the owner returns. The dog tried to follow its owner into the store, but is stopped by the leash. So each day, the dog is 5 feet, 1.5 feet away from the post. We also know that each day, 60 seconds after the owner left, the dog was 4 feet from the post. Remember when we talked about with equations, the first thing you want to do is break down your situation. And so the goal on the next slide is to graph one of these situations. And since I wanted to leave it random, spin the circle and figure out which day you're going to model. I'm going to be modeling day 2. And so when you go to the next slide, right, you want to graph this relationship and think about as you're going through, does this make sense in my context? Each day, the dog was 1.5 feet away when the owner left. So I know that when the owner left, this dog was at 1.5, right? This is at 0 time. Right as the owner left, the dog is 1.5 meters from the post. I also know that each day, 60 seconds after the owner left, the dog was 4 feet from the post. So I know that at 67 time, I know that the dog was 4 feet from the post, right? We have 4 feet here. And now you want to describe the relationship. And we talked about having lines before, but think a little more loosely, right? What is happening to the dog throughout the day? And make sure you read your problem completely. But one thing I want to keep in mind too is as you're drawing, think about what would happen if I'm drawing, and then I loop backwards. Can I go backwards in time? Right, that's something I want you to keep in mind as we're talking about. We're going to really build on that. I have no problem, as I said before, functions are not just straight lines. They move and they react and they could be still for a moment. And so when you are graphing your line, and this is nowhere correct for what day 2 should look like, right? The dog immediately goes 4 feet from the post, then the dog comes down and is 2 feet from the post and goes up again, and always at 4. It is at 60 seconds, it's always at 4. And then what happens? Right? Make sure you're reading each of the directions super clearly as you're going through. So there's multiple correct answers. Just think critically about if you can go backwards in time, what does it mean to go up and down? If time here is my independent variable, right? My x-axis is my independent variable. I know the time, and my result is what is the distance, dependent variable. And my independent variable is always on the x-axis. My dependent variable is always on the y-axis. Right? What am I inputting in? Input your x, get out your y. Input your x, get out your y. And we'll talk about more of that tomorrow as well. But you could see that in the table. I'm inputting an x value and I'm getting out a y value. And so then I want you to get a little bit more practice what your independent and dependent variable is, right? Time in seconds since the dog owner left, and the total distance in feet that the dog has walked while waiting. I know that here my independent variable is time in seconds. I'm inputting the time and I want to find out the distance. My goal is to find out the distance in feet that the dog has walked. And so I know that my independent variable is my time in seconds, and my dependent variable represents my distance in feet as we're going through. And so we know that my dependent variable is a function of, has a relationship to, right, the total distance since the dog walked. Sorry, so the total distance that the dog walked is a function of time, right? Where he is, his distance from the post depends on his depends on where he physically is, right? At 60 seconds, we know that he is blank distance away. At 5 seconds, we know he is blank distance away. So I want you to think about that scenario and all of the relationship between what time represents in distance, and the second case, which the dog since the dog owner left versus the time the dog barked. And I want you to think about those scenarios as well. And so last but not least, I want you to graph one of those relationships and get some practice into that. Remember, this is your independent variable and this is your dependent variable. This is just the beginning of this lesson. So if you are feeling a little overwhelmed with it, then that's fine, right? This is the beginning, this is exploration, and we'll get into the rest of the unit 4 together soon.